Assalamu alaikum. Welcome to my channel Jahangir Science School. Today I am going to discuss about Edexcel IGCSE Certificate in Physics. Unit-1, Chapter-4, Momentum. Edexcel IGCSE Physics pages 40 to 47. All content applies only to triple science. I am Jahangir Alam. I am a science teacher. My contact number is. Welcome to my channel first, Jahangir Science School. This is Edexcel Specification for the chapter. After finishing the chapter, we learned about momentum. Momentum is a product of mass and velocity. It is a vector quantity. After finishing this chapter, we can use the idea of momentum to explain the safety feature of a car. Use the conservation of momentum to calculate the mass, velocity, or momentum. Use the relationship force equal to change in momentum divided by time taken. Demonstrate and understand the Newton's third law of motion. First, we have to learn about what is momentum. Momentum is the product of mass and velocity. What is mass? Mass is the total atom or molecule present in an object is the measure of mass. And velocity, the rate of change of displacement per unit time is called velocity. So, momentum is denoted by P equal to m into V. Mass is measured in kilogram, kg. Velocity is measured in meter per second. Momentum is measured in kg meter per second. So, momentum has both magnitude and direction. That's why momentum is a vector quantity. Remember, when we multiply a scalar quantity with a vector quantity, remember the product always vector quantity. So, remember scalar, if a scalar quantity is multiplied by a vector quantity, then the result is always vector. Remember this thing. So here, momentum is the product of mass into velocity. Mass is a scalar quantity. Scalar means the physical quantity which has only magnitude, no direction. But remember, velocity is a vector. So, overall momentum is a vector. That's why overall momentum is a vector quantity. Vector means the physical quantity which requires both magnitude and direction to represent completely is known as vector quantity. So, momentum is a vector quantity because it has both magnitude and direction. The greater the mass of a rugby player, the greater his momentum. So, the direction of the momentum is the direction of the velocity. Look at the mathematical question. Calculate the momentum of a rugby player. Mass of the rugby player is 120 kg, moving at 3 meters per second. We know momentum equals to mass into velocity, m into v. So, 120 kg into 3 meters per second. So, 360 kg meter per second. Now, question number 2. Calculate the mass of a car that when moving at 25 meters per second has a momentum of 20,000 kg meter per second. We know momentum equals to mass into velocity. There is a formula triangle. Remember, there is a formula triangle. P equal to mass into velocity. So, here we have to calculate mass. So, mass equal to momentum divided by velocity. So, here momentum is 20,000 kg meter per second. And velocity is 25 meter per second. So we can easily calculate the mass of that car. So we can easily calculate the mass of the car. Here mass is 800 kg. 800 kg is the mass. 800 kg is the mass of the curve. Kg. Now next one. Complete the table. Here, look at the table first. Mass 50 kg and velocity 3 meter per second. So momentum will be 50 into 3. So because there is a formula, P equal to mass into velocity. P equal to mass into velocity. So 150 kg meter per second is the answer. So next one, momentum and velocity is given. We have to find out the mass. So momentum divided by velocity, so 8 kg. 160 kg meter per second divided by 20 meter per second, so 8 kg. Now, momentum and mass are given. We have to find out the velocity. So there is a relation between force and momentum. So momentum, what is the significance of momentum? Momentum measures how amount force is needed to stop something which was in motion. So there is a relation according to the Newton's second law of motion. Force is directly proportional to rate of change of momentum. So remember, a force will cause the velocity of an object to change and therefore also its momentum. So the greater the force, the greater the momentum changes. So there is a relation. So we know acceleration equal to change in velocity by time taken, A equal to V minus U by T. So if we multiply M, that means mass, in both sides, then MA equal to mv minus u by t. So ma equal to mv minus mu by t. Ma is the force, so that's why we can write the force equal to rate mv minus mu by t. That means force equal to change in momentum divided by time taken. Remember, unit of force is Newton. And unit of change in momentum is kg meter per second. And time is second. So kg per meter per second square. That means unit of force. So force equal to momentum change divided by time taken. Force is measured in Newton, change in momentum is measured in kg meter per second, and time is second. So there is a question: calculate the force required to change the momentum of a car by 24,000 kg meter per second over 6 seconds. So we know force equal to momentum change divided by time taken. So 24,000 kg meter per second divided by 6 seconds. So correct answer is force equal to 4,000 Newton.